Hello friends, welcome to this video lesson. Today we are going to discuss another important topic, that is applications of normal probability curve part 1. Before starting our discussion, let me to introduce myself. I Dr. Niradhar De, Associate Professor, School of Education, Indira Gandhi National Open University. I am the coordinator of this course of your online course, that is BES 1 to 7 Assessment for Learning. Friends, as you know, presently we are in the 16th module of your online course, and this is also the 16th week of your course. The title of the module is Nature of Distribution and its Interpretation. In this module you will find 3 video lessons are there. First is normal probability curve, its concept and characteristics. Second is applications of normal probability curve part 1, and the third video lesson is applications of normal probability curve part 2. Already we have discussed the first content point, that is the first video lesson, that is normal probability curve, its concept and characteristics, and today we are going to discuss the second lesson, that is applications of normal probability curve part 1. To focus upon the learning outcomes of today's video lesson, I can say that after going through this video lesson as well as part E content that you have received in your module, you will be able to list various applications of normal probability curve in educational measurement and evaluation. You will be able to explain the use of various applications of normal probability curve, and further you will be able to compute various applications of normal curve. That is, in this lesson we will discuss 2 applications, that is application number 1 and application number 2, and in our next session in the application of normal probability curve part 2 we will discuss another 3 applications, that is application number 3, 4 and 5. I am very much sure that after going through this video lesson you will be able to understand that what are the different applications that we can use for analyzing students' result, for analyzing students' data, and further you will be able to compute various applications of normal curve. Now let us recapitulate that what we have discussed in our earlier video lesson, that is concept and characteristics of normal probability curve. First of all, we have discussed that the total area of the curve is 100%, and we know that this is a type of mathematical curve or a type of hypothetical curve or a type of, you can say, imaginary curve, okay, and the total area or the total scores are represented in this figure in this normal curve, and you will find that the entire area of this curve, that is in between +3 standard distance to -3 standard distance, and from 0 to +3 standard distance we say that this is the positive side, this is the right side or the positive side, and from 0 to -1 it is the negative side. Negative sides means from 0 to -3 standard distance you will find that the scores will less than the mean score, and from 0 to +3 standard distance you will find that the scores or all the scores in the positive direction will more than or the greater than the mean score, and beyond +3 standard distance and below -3 standard distance you will find that some extent of score or some extent of the area that is left. So that is why the 2 extreme of the normal probability curve, it never touches the baseline. Okay. So with due respect to the extreme characteristics, extreme abilities of the individual of the population, it may be, if I will give the example of mental measurement, it may be related to intelligence, aptitude, creativity. We cannot say that 0 creativity, 0 intelligence, 0 aptitude. So that is why at both the positive and negative side you will find that the curve, it never touches the baseline, and from 0 to positive side you will find 50% of the cases lie, and from 0 to negative side also 50% of the cases lie, and from 0 to +1 standard distance 34.13% of the cases lie, then +1 to +2 standard distance 13.59% of the cases lie, and from +2 to +3 standard distance you will find 2.15% of the cases lie, and accordingly it is same as in the negative side, that is from 0 to -1 34.13 percentage, -1 to -2 that is 13.59 percentage, and from -2 to -3 that is 2.15 percentage. So this is just for recapitulation, we have already studied, and many a time also you will find that the distribution or the scores that you are getting, that is not exactly normal. So that's why many a situation, many a time we get the distribution or the scores which are skewed, some extent skewed. It may be skewed at the positive side, that's called as positive skewness, or it may be skewed at the negative side, that's called as negative skewness. Okay. Positive skewness means you will find that very few frequencies will be there at the positive side, and most of the scores or the frequencies will be at the negative side. It means it is highly peaked at the negative side and highly skewed at the positive side. Okay. So that's why such type of, which is different from a normal curve, you may get such type of curve keeping in consideration of the score of the data that you are getting, if the data is not normal. And at the same time you may also get a curve or the distribution that is a negative skewed distribution. Okay. It means at the negative side you will find that few courses will be there, the line you will find that the normal curve line will extend unlimitedly at the negative side, and it is highly peaked at the positive side. Positive side means the scores are above the mean, and negative sides means the scores are below the mean. Here in negative skewness you will find that few students score will below the mean, and most of the subjects score, most of the students score will above the mean. So negative skewness like curve is also possible. And apart from this, we have also studied the kurtosis. It means the normal curve, the middle curve here, the middle line, the normal curve is called as a mesocritic like curve. The value of the kurtosis is here in a normal curve is 0.263. A normal curve which is not highly peaked or not more flattened. Okay. It is moderately peaked and moderately flattened. But at the same time you will also find another two types of curve, one is called as leptocritic and other is called as platycritic. A leptocritic curve is highly peaked than normal. Okay. And you will find that the value of kurtosis is less than 0.263, and a platycritic curve is more flattened than normality. Okay. So the value of a platycritic curve is greater than 0.263. Here it may be a leptocritic like curve or a platycritic like curve, both these curves are not normal, but a mesocritic curve is a normal curve. So that's why normal probability curve is also called as a mesocritic curve. And as today's session, after recapitulating our earlier session that already we have discussed, in today's session discuss about applications of normal probability curve. So what are the different applications are there? We have already discussed the characteristics of normal probability curve, and further how we can solve, solve certain problem which is related to normal probability curve by using different applications. So far as applications are concerned, there are 5 different applications of normal probability curve. First is to determine the percentage of cases in a normal distribution within given limits of scores. It means if limit is given, then how to find out the percentage. 2 scores will be given and questions will be there that how many students or what percentage of the students, what percentage of the children will fall between the 2 scores, between the 2 limits. So that is one of the application of normal probability curve. And the second application is to determine the limits of scores which include given percentage of the cases. So here it is just the opposite of the first application. Here percentage is given, you have to find out the limit. A definite percentage you will get, and question will be asked that in between what limit that percentage of cases will come. So that also we will discuss. It is the second application. And the third application is to compare the 2 distributions in terms of overlapping. Many a time you will find that 2 distributions are overlapping each other. Okay. So we will discuss that how it is overlapping upon another distribution. Okay, and in case of there is overlapping, how to find out that what percentage of cases are overlapping? Let the mean scores of another group, two groups are there, two means are also given. Okay, so how many students or what percentage of students are overlapping the mean of the another group? Okay, in case there is the overlapping, we can also do that. This is also another application of normal probability curve. The fourth application is to determine the relative difficulty of the test item. Okay, so what is the relative difficulty of the test item? You will find that in a test we take many items, many questions. So I will ask you how to find out, how to know that which item is difficult, how much. And if I will say that 2 or 3 items are there, among these 3 items, which item is more difficult? And to compare 2 items, I will ask you that how much difficult it is. So such type of questions answer we will get when we use fourth application of the normal probability curve, that is to determine the relative difficulty of the test items. And the fifth application is to provide a group into different subgroups according to certain ability and assigning the grades. So here you see a large group is given. So how to make different subgroups according to the abilities of the students, of the subject. So these are the 5 different applications we will be discussing. In this video lesson, we will discuss first 2 application, application number 1 and application number 2. It means in number 1 limit is given, how to find out the percentage, and in the application number 2 percentage is given, how to find out the limits. So before discussing the 2 applications, let me to highlight, let me to focus that what is the formula, what is the equation of normal probability curve that we will be using for solving the problem. So here you see the equation is just like Z is equal to x minus m upon SD or sigma. Z is the standard score, x is the individual score, and m is the mean score, and sigma is the standard deviation. Okay, so this is the formula, this is the only equation. By using this equation, we can solve different types of problem and we can go for testing the applications of normal probability curve. And here you see this is the table of normal probability curve. Here you see this is the Z score in the first column, this is the Z score, and here also you will find different level or the decimal values. So how you have to find out? I will say that it is 1.25 Z score. This is the standard score. So 1.25 means here you see 1.2 and this is 1.2, then 0.25 in the column 1, 2, 3, 4, 5, 6, 7. In the 7th column you see on the top that is 0.05. Okay, so that's why in the first column in the row of 1.25, you have to follow that row and you will come to the 7th column, that is 0.05. So the value is here, I think 0.02, the value is here 0.3944. Okay, so this is out of 10,000 and out of 1000, and if I will calculate out of 10,000, and if I will calculate it from 100, then it will be 41.15. So accordingly you can use the table. Let us now go forward to discuss the first application with certain example, then the things will very much clear to you. So now focus upon the first application, that is percentage of cases within a given limit. So here a limit is given. What you have to do? You have to find out the percentage. You see in a class mean score in an Urdu test is 26.1. So in a class a test has been conducted in the subject of Urdu, and the mean score is 26.1 and the standard deviation is 6.45. So what you have to do first? You have to calculate the mean and you have to calculate the standard deviation. And in normal probability curve, especially in the applications, you will find that the mean score and the standard deviations are usually given. You have to solve it. Then how many percentage of cases lie between mean and the score 35? So mean is here 26.1 and the score is 35. So what percentage of the cases lie between 26.1 and 35? Equation we have already discussed, Z is equal to x minus m upon st. So here x means individual score. So here individual score is given 35. This is one limit, that is 35, and mean is given 26.1. So mean of the group is 26.1, and sigma, that's the standard deviation, it is also given, that is 6.45. So you just put these values in the formula, then you can get the result. So now to understand that what percent, the percentage of what area that we have to determine, here you see this is the distribution. I have just plotted it in a normal probability curve. Mean is 26.1 and the x, that's the score, individual score is 35. We have to find out the percentage of the cases or the percentage of this area, the red lined area, that is in between the score 35 and the mean score 26.1. And here you see what you have to do, you have to first convert by using the formula z is x minus m upon st. You have to convert, you have to get the z score, the standard score. So just put the values, x is here individual score, that is 35, m is the mean score, that is 26.1, divided by 6.45. So 35 minus 26.1 is 8.9. So 8.9 divided by 6.45, that is 1.38. And now what you have to do, you have to now go through the table. Okay, 1.38, you see this is the 1.3 row, then we have to come to this point, that is 41.62 out of 100. This is out of 10,000. 0.08 in the column of 0.08, okay, in the row of 1.3 and the column of 0.08. So that will be 1.38. It is 41.62. Now let us go forward. Here you see 1.38 standard distance or standard deviation is equal to 41.62 percentage of the cases. So in result we can say that 41.62 percentage of the cases lie between the mean and the score 35. Okay. So one score, the individual score was 35 and the mean score was 26.1. Okay. So that's why here two limits had been given, one is 26.1 and other is 35. We just calculated the percentage of the cases lie between the limits, and the percentage of cases is here 41.62. So this is the application that you will find some limit is given, you have to find out the percentage. Friends, now focus upon the second application, that is to determine the limits within a given percentage. It is just the opposite of the first application. This is application number 2. Here a percentage is given and you have to find out the limits. You have to find out the two limits. Here you see in a class mean score in a test, in an Urdu test is 26.1 and the standard deviation is 6.45. Question is given that find out the limits of the middle 75% of the cases. So here you see a percentage is given, that is the middle 75%. You have to find out the limit of the score. Here you see middle 75% cases spread equally in both the directions of the normal curve. Okay, so let us go forward to compare it, just to plot it in a normal probability curve. You see on your screen now, this is the normal probability curve. This is the middle portion, the red lined mark portion is the middle portion, and this middle portion is 75%. Middle portion means you will find that this is the 0, this is the midpoint of the curve. You will find half of the percentage of 75 will be at the positive side and will be also at the negative side. Then after we can say that this is the area of the middle 75%. So 75% divided by 2 is 37.5%. That means at the positive side 37.5% and also at the negative side the area is 37.5%. Then after getting the score 37.5%, next what you have to do, you have to follow the table. Okay, so the table means here the values that you have to see in the table, that is 37.50%, you see, which is close to 37.50. Here you see 37.49, 37.49 is 1.15. Okay, 37.41 is close to 37.50. So that is 1.15 standard distance. Okay, 1.15 standard distance. Here you see middle 75% of the cases spread equally in both the directions of the normal curve. It means 37.5% from the mean towards the right side and 37.5% from the mean towards the left side. Okay. The value of 37.5% in the normal table, normal probability curve table, I just show you, that is 1.15 sigma distance or standard deviation. This is in the positive side, but at the negative side, you know, the values will be -1, -2 and -3 standard distance. So that's why from 0 to -1.15 standard distance you will find 37.5% of the cases lie. Okay, I have already discussed this figure. Then again, what you have to do, you use the equation to determine limits within a percentage. You use the equation z is equal to x minus m upon sd upon sigma upon standard deviation. So here you see, just you have to solve this equation. Z values already we have received from the table, from the normal probability curve table, that is 1.15 at the positive side. And x, we have to find out the x. X means one of the limit, one of the score. X we have to find out. Mean score is given in the question, that is 26.1, and standard deviation is also given, that is 6.45. So what you have to do, you have to simplify it, and you will find that the value of x is 33.5. So 33.5 will be a score at the positive side, because we have taken here plus 1.15. Okay. And equally at the negative side, what you can do, you have two values of z at the negative side, minus 1.15 is equal to x minus 26.1 is the mean, x is the individual score, divided by 6.45 is the standard deviation. Just you simplify it. So you will get the value of x is 18.68. This is one of the score at the negative side. So that's why in the result we can say that the middle 75% of the cases lie within the limits of the scores, such as 33.5 and 18.68. So one limit or one score is 33.5 and the other score is 18.68. So this is the two limits. So friends, here a percentage had given, then what you did, you just find out the area of that percentage first, the location, the situations of this percentage first, by drawing a normal probability curve. And just like here in this case, 75, middle 75% of the cases, it means 50% of 75% cases, that is 37.50% is at the positive side, and equal percentage is also at the negative side. And 37.50 we got it from the normal probability curve table, that the value is 1.15 standard distance. At the positive side it is plus 1.15 standard distance, and at the negative side it is minus 1.15 standard distance. And further, by using the mean value, standard deviation and the table value or the standard value or the z score or the z value, we just simplify it, and at the positive side we got the score, that is 33.5, and again we simplified it at the negative side. Okay, so here the z value it become minus 1.15 standard distance, and if you simplify it you will find the z value is 18.68. So that's why now we can say that the middle 75% of the cases lie within the limits of the score, such as 33.5 and 18.68. So friends, in this way you can calculate many problems relating to normal probability curve. If limits are given, you can calculate the percentage, and if percentage is given, you can also calculate the limits. Just to recapitulate, today in this lesson, first of all we recapitulate the concept of normal probability curve and how a curve is divert from normality, that is in terms of skewness and kurtosis. We discussed positive skewness, negative skewness, leptocritic like curve and platycritic like curve. And further we discussed the equation of normal probability curve for solving the 5 different applications of normal probability curve, and we also discussed the table of normal probability curve, and further we discussed two applications of normal probability curve. When limit is given, how to find out the percentage, and when percentage is given, how to find out the limits. I think you will take in your module, you will find that many other questions are also there. You should select many questions and you should do the hands-on activities, you should solve it, so that the things will more clear to you. For further queries, you can write to me in radhar@ignou.ac.in. You can make me a telephone call. My intercom is 2994. You can visit my Facebook account, my Twitter handle, that is Transforming Education, and my YouTube channel, that is Transforming Education, and my Twitter handle. In my YouTube channel, you will find that many such more than 250 video lessons are there that addresses different issues of education, and especially many videos you will find that is related to assessment for learning, at the same time on any popular themes on education. Thank you.